Hi guys, so we're back with the second installation of Permutations, Unit 11.1. So now we're going to actually discuss permutations again, a different form of it. It says permutations of n objects taken r at a time. So I have kind of like our last question that we did when we said we had 8 stories and I only wanted 3 of them. This is what we're doing. There's actually a formula that works for this. If I have, it says a number of permutations of R objects taken from a graph of n distinct objects is given by this. So the symbol is given by this P, and this is my number of things I have to choose from, and this is R is the number of things I'm choosing. Okay, and and then it equals n factorial over n minus r factorial. And I'm going to show you how it works using our last example that we did. I'm going to use it doing this. So I had the permutation of 8 choose 3. Remember, I had 8 stories and I only wanted to choose 3 of them. So how that would work, and I would say 8 factorial over 8 let's try and fix that here. Over 8 minus 3 factorial is going to be 8 factorial over 5 factorial. So I get 8 times 7 times 6 times 5 factorial over 5 factorial. And if you remember last time we had 8 times 7 times 6, which is 336 ways. Okay, so that was just an example. Now the problem is why we have this formula is because sometimes they don't always give us context in which to do the problems. They just say find the number of permutations. Hence our next 2 problems, they just give you 6p2. 6, choose 2 permutations. Give me 6, they want me to choose 2. So there's no story context. I can't say, okay, I'm going to choose this many. What is it? Okay, so I need to kind of work it out a little bit. Pretty sure that I kind of know the answer to it a little bit. It's probably going to be what, 6 times 5, right? Let's just see what it is. So I've got 6 factorial over 6 minus 2 factorial, right? So that would be 6 factorial over 4 factorial, which is 6 times 5 times 4 factorial over 4 factorial. Yep, which equals 30, right? I'm just taking the first 2. Basically what I'm doing is I'm taking the first 2 terms of 6 and multiplying them together. For the permutations, this works. So on the second one, if I go by the same reasoning, and it's worked both times, so I just want to kind of point this out. On this one, I took the first 3 of the 8 times 7 times 6. It works on permutations. So that means that on the next one, where it says 12, choose 2, that means I'm going to have 12 times 11, which should be 132. Okay, permutations, that works. We're gonna once we get to combinations, or the other types of combinations. There's another type of permutation that it does not work on. But if we're just doing a straight permutation, 6 choose 2, 11 choose 4, it's just the first 4 numbers, or the first how many ever I'm choosing. I'm going to multiply them together. I hope that kind of makes sense. If not, please let me know. So the next one is a story problem. We have a story problem about it, and it says how many different ways can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize. So we're still doing the same thing. So I have a permutation. I have 50 choose 4. So I know, because I want to choose 4, right? I know that I'm going to take the first 4 of 50 in descending order. So that's going to equal 50 times 49 times 48 times 47, the first four terms, and multiply them together. Well, once I multiply them together, it's 5,527,200. And if you want to check my work, by the way, there is a way in your calculators that does permutations also. In Desmos, it's found under, you go to the functions button and it's under stats, and it's, I don't know, third or fourth row down, you have to look. It says NPR. So you find the NPR button. In your other calculators, again, just Google it. They'll show you how to find it depending on what calculator you have. And then you just put in the numbers however they tell you to, and the answer will pop up for you. Just make sure that you know how to do this. Okay, so for now we are going to pause, and you're going to do some problems, and we'll come back for the last part. I'll see you guys in a few. Bye-bye.